Welcome. Today's case is a laser-assisted cataract surgery with a femtosecond laser by LensX and Alcon with a Hydrus glaucoma stent by Vantis. You can see the CAPSULORHEXIS being removed here. It's been performed by the femtosecond laser and it's just being removed from the surface of the lens cortex. HYDRODISSECTION is done with a 27 gauge cannula with BSS on both sides, allowing the lens to spin freely within the capsular bag. Once we have a thorough hydrodissection and the lens is able to spin and rotate easily, then phacoemulsification can be performed. Here you see the second instrument. I use and prefer a Untitled Chapter to break up the pieces of cataract and start to remove each of the sections. Obviously, the laser having made this a bit easier and faster for the phacoemulsification step. Removal of lens cortex is then performed with the irrigation aspiration handpiece, taking away pieces of the lens cortex. Implantation of the intraocular lens is done through the 2.2 millimeter wound with a single piece acrylic lens, an SA60 WF model, lens implant, which is placed perfectly into the capsular bag and then folds very nicely and easily. Here is irrigation aspiration of the VISCOELASTIC material, and then entry into the anterior chamber of LIDOCAINE and MIOSTAT to assist the next procedure, which is the Hydrus glaucoma stent. Here I make the incision to implant the Hydrus glaucoma stent, making this 4 clock hours away from the angle insertion point, and adjustment of the microscope to get a nice view into the angle of the eye. Here I use an OCULUS GONIO prism, which we place on the cornea to overcome the internal reflectivity of the cornea and achieve view of the anatomic angle. There it is. Beautiful view of the trabecular meshwork and anatomic angle. We'll check the Hydrus stent and then approach the anatomic angle to see our anatomic landmarks. High magnification is important to get the best view. We're going to target above the scleral spur and below Schwalbe's line. That area is the pigmented area or the trabecular meshwork. When we insert into the meshwork, we can actually feel the posterior wall of Schlemm's canal. This stent acts like a scaffold, opening up Schlemm's canal, stretching trabecular meshwork, and increasing outflow into the natural drainage system of the eye. Here we are gaining access to the canal through the trabecular meshwork with enough posterior pressure to be in the canal. First eyelet goes in, back off and level out, release the stent. Very nice placement here. The transition zone is already halfway covered by trabecular meshwork, so we have a nice depth of insertion, so not too much ingesting to be done. Here we'll go back in slow motion and kind of see that first eyelet going in here. The canal is being stretched. I'm still married to the back of the canal and releasing the rest of the stent into the canal parallel through the canal length. So a quick finish to the end of the case. The viscoelastic's been removed. The incisions are being sealed. You can see the Hydrus is in place and the lens implant is in the capsular bag. I'd like to acknowledge and thank the doctors who've helped me learn these techniques, including my local representative, Ben Gonzalez. Thank you for watching the case.